I am Al Freeman, and I'm going to show how to tune an embedded antenna and measure antenna efficiency with aid of my antenna designing software, AnTune. In opposite to most RF simulation softwares, is AnTune a smart real-time designing aid and is connected to a network analyzer. This kind of job can take several hours just for tuning, and additional time to measure antenna efficiency in an anechoic chamber. It is a very easy and quick job to do with aid of AnTune. I will now show every step very detailed, and it will take less than 10 minutes. If something is unclear, please comment and I will try to answer. Here is the instrument I will use with AnTune. It is a single port analyzer, a model R60 from Coppermine technology. It is well suited for this kind of job. Tuning an antenna and afterwards verify antenna performance by measuring antenna efficiency. R60 is connected to PC for both power and communication with a USB cable. Practical and simple. Ferrites reduce reflection currents. Can never have too many ferrites. Cable is medium quality and rather short but long enough to cover lab table. No real need for high quality cable as long as cable not is spent too much. Cable losses are no problem as they are compensated for at calibration procedure. What antenna to tune? My idea is to do an antenna retuning just for fun and a bit experimental. Antenna is inside this earpiece and is now tuned for 868 MHz. I will try to reuse same antenna and tune it to 2.4 GHz. I am not sure if final result will be good enough, but it is the actual exercise to show how to do this kind of job that is the interesting part. A special part is to show how to measure antenna efficiency directly at lab bench in less than a minute instead of using an anechoic chamber, which takes a lot of more time than a minute. This function is only available in AnTune, but principles are very old, known as Wheeler's cap. It is more interesting to be able to measure antenna efficiency during antenna design phase than knowing that antenna have a low standing wave ratio, so it is a very useful function. Let's investigate earpiece inside and prepare it for measurement. Earpiece contains a ceramic antenna designed for 868 MHz. It is possible that it becomes a bit lossy if retuned to 2.4 GHz, but we will give it a try. At top of PCB is the ceramic antenna. It is a Mitsubishi antenna. Below antenna at marketplaces are currently 3 tuning components. As seen from antenna is it a 0 ohm resistor, a serial inductor and a parallel inductor. Measurement cable with its ferrites are soldered as this. Notice cable is leaving PCB at a non-hot RF area. To set up R60 analyzer instrument, start its software from Coppermine software. If not done so before, open and check that its network is open for connection. Frequency range must be set to something fitting actual measurement. Here is a previously saved frequency range that cover on it for 868 MHz antenna. Next step is S11 calibration. Open, short and load. Confirm for each setting. Press apply to save these settings, and now can this window be minimized. Earpiece is now connected and we can check actual tuning. Markers are set to interesting tuning range and the antenna seems to be tuned for expected 868 MHz. But this was just a quick check if antenna was working at all. Existing matching network is therefore now removed, leaving coaxial cable open, only connected to the empty matching network pads. Set new frequency range to 2.2 to 2.7 GHz and then recalibrate. In AnTune do we now set visual tuning frequency by selecting fitting marker frequencies. An important calibration is to set correct port forwarding, amplitude and timing. It is very easy to do in AnTune. Just push button marked call set, which here is covering tuning component pads in an open circuit. As an alternative, can a shortcut to ground be created with an exactor or a soldering blob? A short wire is soldered so that antenna is now connected to the matching network. Is earpiece put together and placed in hand for a likely antenna load. AnTune do with no delay deliver a proposed network, which we save as well as by AnTune predicted impedance curve. Step by step is each component replaced with real components and result is verified for each step. If needed, can a component value be adjusted for each step so that finer tuning becomes as similar as possible as by AnTune predicted curve. By doing this job in steps, is it no risk to get an unexpected final result. Saving curves and files for each step makes it easy to check if or where something goes wrong, and it is easy to take a step backward if needed. If tuning result is good enough, can we take next step and measure antenna efficiency? That function must be unlocked if not done so before. By unlocking, do you confirm that you understand that this function needs some knowledge to be of skilled use? The shielded box needed for this measurement can be any small metallic box, almost. I have used both cookie can and stainless thermos with same result. Function is to block antenna from radiating by near-field lossless shortcut. A number of information and warning signs may pop up during this phase. They can in most cases be ignored, as they mostly are for your information. When a calibration measurement is done, can antenna be held in free space, or in what environment antenna efficiency should be measured? And the efficiency can be read for full measured frequency range. Quite handy. If a certain frequency range is performing poor, can that now easily be investigated live at your lab bench?